All right, this is AZMerit Review number 3. Write an expression in the box below that is equivalent to this. This is in radical form. Exponential would be whatever's on the outside goes down below. Whatever's on top here goes up above. Number 2, identify which expression is equivalent to 4. Well, there's a couple different ways to do this. One is just grab a calculator. We're going to go one by one and find out which expression or expressions is equivalent to 4. So I could take 8 to the 0.5. We know that's the square root of 8. We can see that's not right. I'm going to come back to B. I can take 64. Now, there's often a lot of confusion. How do you do this? Remember, this is not 64 to the third. It's always 1 over this number. So 1 divided by 3. That is equivalent to 4. Then we have 16 to the 0.5, and that's like the square root of 16. That is also 4. And let's check this last option. So I'm going to take 8 to, not 8 to the third, but it's 8 to the 1/3. Okay, and I'm going to take it times 4 to the third. That's my numerator, 128. On the bottom, I know the square root of 4 is 2. So 2 times 2 to the 4th is 32. And if I take 128 divided by 32, I end up with an answer of 4. Correct answers would be B, C, and D. Okay, part 3 says, which procedure shows a valid method for solving this? Okay, so if I want to isolate the x, we're going to do PEMDAS backwards. First, I'm going to subtract 5 to the opposite side. I have negative 2 times this quantity equals 6. Then I'm going to divide by negative 2. All right, now, remember, there's another way to rewrite this. It's really x plus 3 to the 1/3. So if we're trying to isolate the x, how do I get rid of the 1/3? I'm going to raise both sides to the third power. And doing so, these cancel out, turning into a 1, and I'm left with x plus 3 equals, okay, let's put this in parentheses and get a value and then subtract 3. Let's get a value and then subtract 3. Keep this in parentheses. Negative 3 raised to the third, get an answer, and then subtract 3 so you have x isolated. So negative 30 is my answer. Is there any negative 30s? 1. There's the correct answer. Okay. Number 4. Evaluate this expression and write your answer in the box below. Remember, any number to the 1/2 is taking the square root. So the square root of 16 is 4. Just showing you how you can do this on a calculator. 16 to the 0.5 is 4. So this answer is 4. Okay, I'm going to start with this one inside. What number times itself 3 times gives you 125? We know the answer is 5, but how could you do that? We have 125 raised to, not to the third, but to the 1/3. So this answer is 5. This answer is 5. Now, there's often some confusion. Do I multiply first or do I square it? Think PEMDAS. What do you do first? Exponent. So 5 squared is 25. What's 25 times 3? So I have 75 plus 4, which is 79. Next page. Which procedure shows a valid method? My suggestion would be to work through this, okay? Would be to work through this. All right. Remember, we always have to keep in mind of answers that may be achieved correctly through math, but when you plug them back in, it doesn't work. What are those called? Extraneous solutions is correct. Okay, here we go. I'm going to rewrite this right away, just my preference. I'm going to write it to the 1/4 in rational exponent form. Okay, so on the side containing the x, doing PEMDAS backwards means get rid of adding and subtracting. So I'm going to subtract the 7 to both sides. If you see me make any small mistakes, please let me know. And 19 minus 7 is 12. Now I want to get rid of this 3/4. Now it is being multiplied times this quantity, so dividing by 3/4 is not mathematically wrong, but we teach you to make things just a little bit prettier by multiplying by the reciprocal. The 3's and the 4's, we say they cancel out, but really what do they turn into? The number 1. And 12 times 4 divided by 3. 12 times 4 is 48. 48 divided by 3. Or you could take 12 times 4/3. 12 times 4/3 to get the same answer of 16. Okay, now what's my next step? It is me to raise both sides to the fourth, or 4 over 1. Cancels, turns really into 1, and I have x plus 3. Please take 16 to the fourth. And we have this large number, and now we are going to, last step is going to be to subtract 3, and I have x equals a final answer of 65,533. Correct answer is D as in dog. Okay, what is the next step in solving this? Well, what is the next step in solving? Well, I need to isolate this radical, so I'm going to subtract 1 from both sides. So the square root of x subtract 7 is equal to 3. Is that an option? X subtract 7 equals 3. X subtract 7 equals 3. Okay, that's good. All right, good to go. So I can't eliminate any answers. Now, remember, to get rid of a square, I'm going to square both sides. Whatever I do to one side, I must keep it balanced and do it to the opposite side. X subtract 7 equals 9. And then the very final thing is to move the 7 to the opposite side. I'm going to add it to both sides to come up with an answer of 16. Is 16 one of the answers? Did I do my math wrong? What'd you say? Oh, just the next step. Okay, gotcha. So I went too far, didn't I? Okay, so I should have x subtract 7 equals 3. Okay, got that. And then I should square both sides to have x subtract 7 equals 9, which is right here. We're so used to having it go all the way to the very end, I guess that's where I confused my own self. Next part. All right, average rate of change. I must not do a great job of teaching this. I know it's taught freshman year, but we do it in this class because consistently students are confused. How do we do average rate of change? Please circle that. We associate that with a slope, y sub 2 minus y sub 1 over x sub 2 subtract x sub 1. So we're saying on a specific interval of a graph, how fast is this graph rising or declining on only a specific part of the graph? So this is an interval. These are both x values. We don't know their corresponding y value. This is my first x. This is my second x. This will be my first y, and this will be my second y. So to do this right now, I'm going to take this -4, and I'm going to put it right into here. So this would be, if I substitute this in, this would be -4 to the 1/3 subtract 2. -4 to the 1/3 subtract 2. And this would be -2 to the 1/3 subtract 2. So we're taking rate of change, which is like the slope on a specific interval, and now we've just complicated it with a harder radical problem. What is the average rate of change on this function? By the way, let's make this equal to y, so it is a function. Okay, so it's going to be y sub 2, so -2 raised to the 1/3 subtract 2, subtract y sub 1, -4 to the 1/3 subtract 2, all over x sub 2 subtract x sub 1. All right, so we got the basics down here. We do want to round our final answer to the nearest hundredth. Okay, are you ready? So let's watch really quickly. Let's figure out what this answer is, and let's figure out this answer, and let's subtract them. Let's figure out this on a calculator, figure out this, and let's subtract them. Let's start with the first one. In parentheses, -2 raised to the 1/3 subtract 2. Make sure you have the same answer that I do. Hands raised when you do, please. Maybe only about a third of you. Can you help your partner if your partner doesn't have it, or vice versa? Okay, that's this answer. Now we want to subtract that from this next answer. So I'm going to leave that here, because remember, we don't want to round to the very end. If you round and then round again, your final answer won't be as accurate. So we're going to go subtract. This answer subtracted, now I'm going to do a parenthesis. Okay, so that's like the beginning parenthesis of this entire thing. And notice that there's little parentheses around this. So I'm going to do parenthesis -4 raised to the 1/3. Bring it down, subtract 2. This was the beginning parenthesis. Now here's the end parenthesis. This is the answer in the numerator position. Can you raise your hand if you have the same that I do? Okay, give me 1 second. Okay, now we need to divide that by, do a parenthesis. And let's do it. We have -2 subtract a -4. Make sure it's in parentheses. -2 subtract a -4. It says to take our final answer and round it to the nearest hundredth. So my final answer is the rate of change on this interval is approximately 0.16. Check with your partner, please. Kimberly shifted a graph of the function 3 units down and stretched it vertically by a factor of 2 and then reflected it across the x-axis. What is the equation of the newly created graph? So my new graph, and I'm just going to call it f of x. It's the new graph. I want to stretch it vertically by a factor of 2. So 2's out front. Okay. And I want to reflect it across the x-axis, makes that negative. And I want to shift it 3 units down, so our vertical shifts are in back. Here's my new equation, taking g of x and translating it 3 down, restretching it by a factor of 2, and then reflecting it across the x-axis. Please flip over and find number 9. Monique solves this problem, and then she realizes she made an error. My personal preference is whenever I have this happen, I think it's easier personally to go off to the side to do the work and then to check to see and compare my answer with the answer given. So I'm going to do that right now. So my first step would be to divide by -2. And then I would square both sides. And then I would subtract 4. So I want to get an answer of 32. Okay, let's see what Monique did. So Monique realizes she made an error. So step 1 goes from here to here. Did she do something wrong in step 1? She sure did. Okay, so step 1 is the first mistake. And why is this step selected above incorrect? So what did she do wrong? Monique did not isolate the x correctly. She should have added 2 to the right side. So in order to isolate this radical, should she have added this 2 over? Nope. Okay, cross it out. Monique divided by 4 incorrectly. So going from here to here, we didn't divide by 4. Cross that out. Monique should have isolated the radical before squaring both sides. So do you agree the first step is divide by 2 so that this is by itself and then square? Correct answer is C. Can I have right now a 1 through 5, your level of understanding things so far? Write the correct answer in this box. So actually this is just the problem up above that I just did, so you can look up here. I just did this problem, it's the exact same one, and x equals 32. Okay, going on to number 10. Given this function and what we see in g of x, so we have a quadratic and we have a radical. And we want to look here to determine which ones are true. Okay, So we have this one. Now let's plug this into our calculator. Please do second plus 7, 1, 2. Second plus 7, 1, 2. And we have, okay, so how do we do square root? Well, let's start with the beginning parenthesis, because I can see this 1 is not within this radical. So the square root of 2x plus 5, and I want to make sure that the parentheses goes on the outside, and then subtract 1, and I want you to make sure that your graph looks like mine. Is everyone okay? Chase still awake? Awesome. Okay, so we have these two functions. Okay, let's go ahead and we are going to compare what we see here and what we see here. I'm going to read number 1 out loud. It says, so for all values of x, your y value for f of x, that's referring to your y value for this function is always greater than your y value for this function. I don't know. Let's check. So let's do second table for all values. Well, let's check with -2. Do you agree on this graph it continues to go down and down and down and down and down? Yes? So there will be an answer over here for -2. Do you agree it's going to be a really small number? Like, I'm going to just take a guess. Maybe like -10 or -20. It'd be something very small. And here, -2 goes with 0. This statement once again says these numbers, y values will always be greater than these y values. These y values will always be greater than these y values. So, yes, this y value is greater than a potential like -10 or 20. Let's go to 0. So when x is 0, what do you think this is? Take a guess. What do you think 0 goes with? 0 maybe goes with -4 or 5 if we were going to take an estimate. 4, 5, 6. 0 here goes with 1.2. So yes, f of x is still greater. What does 1 go with? 1 goes with, on this graph, 1 goes with 1.6. 1 here goes with about -1.5. What does 2 go with? 2 goes with 2, and 2 goes with 2. Oh, they're the same. This says for all values, this is always greater than this. So 2 goes with 2, and 2 goes with 2. That tells you that this is not greater. So I don't have to go any further. 2, a value of 2, is not greater than a value of 2. They're equal. Now it gives you a specific range, and I find it easier for myself to kind of highlight that range. So I'm looking at the graph from 2 to 8. So from 2 to 8, I'm looking at this graph right here. Okay, and then I'm going to come here, I'm going to go just from 2 to 8. So it's an interval of x's from 2 to 8. So on that interval, and let's look up here, let's do second and graph again. On that interval, it now says that g of x, these values are always greater than these values. Well, let's check, okay? So it says these values are greater than these values. What is the value of 2? 2 goes with what? 2. Okay? Do you see how it says greater than or equal to? So my question for you, is 2 greater than 2? Yes or no? No. Cross it out. Okay, the next one says that as you go to the far left, end behavior, as you go to the far left, this answer is greater than this answer. As you go to the far left, this answer is greater than this answer. Also not true. We can see that it continues to go down, and we know with the radical this is actually going to stop here. Now as you go to the far right, to the very far right here, which way is this graph headed? Down. Which way is this graph headed? Slowly up. So is it true that f of x, is it true as we go to the far right that the values here, the y values will be greater than the y values here? The only correct answer is D. Okay, going to answer our very last one from this packet, and it is number 11. Please have one person read it out loud. Okay, are you guys ready? So I'm a visual learner, so I'm going to do the following. I'm going to grab a piece of paper that I can graph on, something that is blank. Give me 1 second. And I'm just going to sketch this out. You're welcome to use any of this area here. Maybe that's enough space for me to do it as well. So I'm going to do the following. Please do it with me. I'm going to go 0, 2, 0, 2, and 1, 1, and 2, 0, 3, 1, 4, 2, and 5, 3. It states that f of x function is an absolute value, and I can see that. So there's f of x. And g of x is a radical function. I'm going to do it in a different color. So I'm going to just approximate. So now I'm going to go to 0, 0, and to 1 and about 0.9. This is just estimation. Over 1 up approximately 0.9. And then over 2 and up about 1.25. Over 2 and up about 1.25. Over 3 and up 1.5. Over 4 and up 0.8. Over 5 and up 2. Select all of the intervals in which they are equal. Okay? So first of all, turn to your partner. By visually, how many places are they equal? Turn to your partner. 2 places. Would you guys agree? Okay. So now my graph is not beautiful here, but let's see here. Between 0 and 1. Do you guys agree that between 0 and 1, it's close, but they actually don't cross yet? Now, between 1 and 2, I have them crossing just a little bit past 1. I have them crossing here between 1 and 2. Between 1 and 2, I have them crossing over. Do you guys agree this point right here is just a little past 1, x value of 1? So I get to go between the interval 1 to 2. These are both x values. Where do they cross again? They'd appear to cross right here, which is 1, 2, 3, 4. It's between 4 and 5. Will you guys please look at your graphs and see if your graphs look similar, that's between 1 and 2 and 4 and 5. Can anybody confirm with me that I actually graphed it? By a raise of hands?